Good morning, Hamilton County 4th graders. I hope you're having a great Friday. We are week 4, day 5 today. Yesterday, we introduced angles using page 302 through 303 in the instructional book. We did our practice and we did our daily countdown. Today, we're going to expand on our knowledge of angles. And so, to start, yesterday we talked about 3 types of angles. Real quick for me, go ahead and say out loud the 3 angles that we learned about. We learned about the right angle, the acute angle, and the obtuse angle. What were the characteristics of those 3 angles? Think about it for a second. Pause the video if you need to. Well, we know that the right angle is 90 degrees, and it stands straight up and it makes an L. We know that the obtuse angle is going to be larger than a right angle, so larger than 90 degrees, and it's going to be a very open angle because it's bigger. And then we have an acute angle, which is less than 90 degrees, and it is a much smaller angle, so it's a little bit more closed in. What else did we learn about angles? We learned that angles are made up of either lines, line segments, or rays. What is the difference between a line segment, a ray, and a line? Well, if you don't remember, a line goes on forever or for infinity in both ways. A line segment is a line within a line. So here's your line. Your line segment is just a piece of that line. So do line segments go on forever in either direction? No. They are literally just a spot in that line. And then we have an array that starts at an endpoint and goes on for infinity or forever in one direction. And then, of course, the other vocabulary word we learned was the vertex, which is the spot where 2 rays meet at an angle. This is the vertex. Okay. So now that we have that review out of the way, let's talk about what we're going to do today. So today, we are going to take that knowledge we have of angles and we're going to put it to some use. So, the way that we measure angles is by degrees. The reason why it's by degrees is because an angle is measured in accordance to where it cuts through in a circle. Remember that a circle is 360 degrees, and an angle is counted by 1 degree. Now this protractor here, it looks a little differently. Like normally a protractor will look like this, but this is the only interactive tool that I could find, and so it kind of works as a protractor, as it does have a vertex point where the angle's vertex needs to line up at. It does count by degrees and it measures the angle, but it only does it by 5. So it starts at 0, 5, 10, 15, 20, so on. Whereas a normal protractor, you have the notches that, let me see if I can't, I was playing around with it. So the notches, this would be a 1 degree angle right here. That would be a 1 degree angle from the center of the circle. This would be the 2, 3, 4, 5. See what I'm talking about? And as we move that angle up, we're moving it by 1 degree. So this would be, this right here would be 5 1 degree angles, or 5 degrees. This would be 10 1 degree angles, or 10 degrees. Did I say that right? 10 1 degree angles. Yeah, I did. Okay. Anyhow, so when we're measuring with a protractor, We have to line the angle up exactly in the middle. So if we wanted to find, let's say, the angle of, let's see, well, let me do it here. Yeah, okay. So if I wanted to find the angle for, let's call this A, B, and C. So the angle that we're looking at is this angle right here, A, B, and C. So if you think about it, what letters representing our vertex? The B. So we need to make sure that this angle is lined up exactly in the middle of our protractor. And then what we're going to do is we're going to move our protractor like so until it is perfectly aligned with my angle and my vertex B. This shows me that the angle between the angle ABC is 90 degrees. Now that's, if you're wondering why I'm calling it A, B, C, because that's the name I gave my angle. All it is I gave a letter for each point in my angle. That way I'm not confusing it with, let's say, if I wanted to measure this angle right here. This angle would be ADC. Sorry, it's just a little skewy. And I would show it like this. ADC with my little angle symbol. Okay. Now, because this is a square, I know that no matter how I turn this square, what angle I look at inside this square, it's going to be 90 degrees because that's what a square is. It is a 90, each of its sides are exactly the same, and so it's going to have the same measurement of angles. Now, let's look, if I wanted to measure, let's look at this angle. Alright, so now I'm going to name these angles. We will have, I don't want blue because my shape is blue. Let's just do black. So we're going to measure this little baby angle right here. So that's going to be A. That's the first line. And I'm going to follow that down. This is my vertex, B. And then I got to do this line as well, and this will be C. So I'm looking for the angle measurement for the ABC. And so what we're going to do is we're going to turn off our pen and we're going to move the protractor to find out that our angle ABC is equivalent to 65 degrees. Let's do another one. So that would be an acute angle. That's a good example of an acute angle. Let's look at something that would be larger. Let's look at this shape right here. And this is what kind of shape is this? It has 1, 2, 3, 4, 5, 6 sides. So what kind of shape is that? That is a hexagon. And we are going to measure one angle inside this hexagon, and it's going to be this angle right here. And I'm just going to name it because I don't have names for it. And I don't want to get confused. Remember, when we're writing these names for these angles, the middle letter always represents the vertex. So A, B, C, this could be F, G, C. I mean, it doesn't go by alphabet, really. I'm just doing that for, you guys, but you could have, it could be anything from, L, B, and A. Just know that that middle letter is going to be your vertex point. Alright, so let's get to measuring. We're measuring angle A, B, and C. And that's going to be, whoops, I totally did not do that right. I'm sorry, guys. We were not measuring the small angle. We were measuring the large angle. So I got to follow that. So this would be, if this is the angle I'm measuring, this would be A. I got to follow that ray. I did not follow that ray. See how easily that can be get messed up? Alright, so now I'm going to go and I'm going to find out that this angle is 120 degrees. So that would make it an obtuse angle. Excuse me. My throat is dry this morning. Y'all getting the hang of that? If you want to play with this app, you can just go to this website up here, or you can just type in free math apps right here, and it's going to be like the first one down, free math apps, and this is what it's going to look like. You can play with number frames, number lines. Right now we are in the pattern and shapes, and you would just go to open in web, and this is your protractor tool. I would really recommend if you guys could go, can play around with those. They're a lot of fun, and it makes it a little bit easier to understand. Anywho, let's do one more, and then we'll get straight into the book work, okay? Let's take this triangle, and we are going to measure. Can I make it bigger? No. We are going to measure. This will be our vertex because that's where my angle meets. And I'm going to follow my vertex up. This would be the first ray and the second ray. Alright. We're going to come back to 0, and we're going to move up until we meet, until we're lined up with this line right here. So we're moving 5 degrees, so this is 5 degrees of a 360 degree circle, 10 degrees of a 360 degree circle, keep going, keep going, keep going, and we're gonna, stop too soon, it's not quite there. So this is a 60 degree angle, meaning it is acute. Alrighty, so that was a little tutorial. Let's get into the packet. Day 5, page 306 to 307 is where we are going to start. Alright, so it said in lesson 28 you learned that an angle represents a turn through part of a circle, and that the measure of an angle is the number of degrees of that turn. Now take a look at the problem. Alright, so all that's saying is that we know now, just by doing this little exercise over here, we know that when we measure angles, when we measure angles, we're measuring the turn the angle's making through the circle. Remember, this would be, this would be a 5 degree turn, 10 degree turn, 15 degree turn, 20 degree turn, and so on. Now, looking at the picture, it says both circles below are divided into 4 equal sections. Estimate the measure of the red angle in the circle on the right. So I'm going to have to look at my book because I did not print these in color. Where did my pens go? Okay, so this is the red angle. And then this one is the blue angle. Now let's look first at what fraction of a circle is one section. It's broken into 4 equal parts, so each of these sections, not the angles, each of these sections is 1/4 of the circle. How many degrees are in the circle? We know that there are 360 degrees in a circle. We need to start making that degree symbol. So please make sure that you're noting that in your math book, or you're writing the word degree. How many degrees are in one section? Well, in one section, let's not look at this one. In one section over here, what degree of an angle is this? Just looking at A B, and C. What degree of angle is that? That's a 90-degree angle. That's a right angle. Look at the circle on the left. How many sections does the blue angle go through? It goes through the same... No. Okay. Sorry, Katie. Look at the circle on the left. How many sections does the blue angle go through? It only goes through how many sections? Is it over here, going into this section? No. It goes exactly into one section. The measure of the blue angle, we already said, was 90 degrees. Explain how you could estimate the measure of the red angle. So if we know... Hang on, let me pause real quick and take this call. Okay, sorry about that. So we were explaining how we could estimate the measure of the red angle now that we know the measure of the blue angle. Well, the blue angle is a 90-degree angle. So we know that this is the blue angle. This would be A, B, C. The red angle we'll call D, E, F. Well, actually, it'll have the same vertex, so it would be B. So, if this angle is 90 degrees, this looks like it's about half of that. So we know that it's going to be less than 90 degrees. And it looks like it's going to be half, so what's half of 90? Well, if you were to divide 90 by 2, you would get 45. 4 goes into 8, or 4 goes into 2 8 times, and 2 goes into 10 5 times. So, our answer is going to look like this. If we know that the blue angle also known as ABC is a 90-degree angle, angle DBC is smaller. We also can see that angle DBC, or the red angle, is half of angle ABC, or the blue angle. So, angle DBC is 45 degrees. If you need a minute to write that down, or if you want to write your own response, I always encourage you guys to try and put it in your own words and then see how those words match my words to see how different we thought. But you can always pause the video. Alright, so the back of this page is just talking more about how we measure angles. So angles that show a turn through 90 or 180 degrees are useful benchmarks for estimating the measure of unknown angles. So, when I'm going to ask you the benchmark angles, you would say, like if I were to ask you what are the benchmark angles we can use to measure unknown angles, you would say 90 degrees and 180 degrees, because those two angles will always look the same. A 90-degree angle goes completely up and makes a perfect square corner. A 180-degree angle is a perfectly straight line. If you want to know the number of inches in a line segment, you use a ruler. What tool could you measure the degrees in an angle? Okay, so this is just introducing the protractor. A protractor is used to measure angles, a 360-degree protractor. So this is a 360-degree protractor, meaning you can measure angles that are much larger than 180 degrees. Most angles that you will measure are less than 180 degrees, so most protractors you use are only going to be half of that. And then, of course, you use the degree symbol instead of the word degrees. So 90 degrees means 90 degrees. How is a protractor like a ruler? How is it different? Take a look. How does this look like a ruler? Well, you could say it looks like a ruler because it has numbers in order and short marks, just like a ruler. So, how is it different? It's different because it's round instead of straight, right? And the numbers count by tens instead of ones. So, if you look, let me see if I have a ruler handy. I probably don't. Oh, I do. Cool. So, here's a ruler. If you notice the characteristics of a ruler, it is a straight line. It has little tick marks that symbolize different numbers. So we have 1, 2, 3. This would be 1 and 1/10. It looks like this is split up in tenths. Whereas a protractor, we still have the tick marks, but is this straight like a ruler? No, it is not. So, zoom back out. So, a protractor is like a ruler. This over. I just can't seem to get in a good spot today. A protractor is like a ruler because it has numbers in order, right? It has numbers in order and tick marks between the numbers. A protractor is different from a ruler because it is round and not straight like a ruler. Here we go. Someone said they were having a hard time seeing, so I'm going to try and zoom when I can zoom and pause it. There you go. You can pause it there. And then we'll go back to this first page in case you missed that last one. And pause the video here. Make sure you have that written down. And we're moving into our practice book. We're getting close to that 30-minute mark, and I hate having these videos run more than 30 minutes because it makes it so the load time is so insane. Alright, so we're on our practice page 311. It says, Logan sketched the front of his townhouse. He labeled the angles in his sketch. Fill in the table below to identify angles V through Z as acute, right, or obtuse. So, we need to look at our angles. We have an angle here, an angle here, an angle here, here, and here. So, an acute angle is going to be less than 90 degrees. So anything that, let me clear that out, yes. So anything that is less than this 90 degree mark, so if it's 89 degrees, it's going to be acute. If it is 60 or lower, it's going to be acute. Any of these angles are going to be considered acute. Get a good visual of that, how that looks. Then let's go back and look at this first top angle. So is that going to be more than 90 degrees? Fix yourself. No, it's going to be less than 90 degrees. So we're going to put it over here. Angle V. Then let's look at the next one, W. W is pretty wide. It doesn't go straight up like a right angle, nor does it make like a V shape like an acute angle would make. So it's going to be more than 90 degrees. And that falls under the obtuse category, more than 90 degrees. Angle W. Then angle X, that should be pretty easy. It's making a very obvious L. So it's going to be the right angle, 90 degrees. And so will Y. And then we have our last angle, angle Z, which looks a lot like our angle W. So this is going to be what? Is it going to be acute, right, or obtuse? It's going to be obtuse. Angle Z. The next few problems, you're going to write A for an acute angle, R for right angle, or O for an obtuse angle. So number 1 says identify and label the 3 angles in the sign at the right. So let's see. Let's look at this first angle right here. What type of angle is that? Does it make an L? Does it make a V? Or is it much wider? That's going to make a V. And so we're going to know that that's going to be less than 90 degrees. And if it's less than 90 degrees, it is acute. And looking at this triangle, it looks like all of the sides or all of the angles are congruent, meaning they are the same. So I'm going to go ahead and I'm going to say that's going to be acute and that's going to be acute. Or you could just look and see, oh, this makes a V and not an L. That's going to be an acute angle. Number 2, looking at these angles right here. This one, this one, this one, and this one. What kind of angles do those make? If you look, this looks like a perfect L, doesn't it? And I can make a perfectly square corner coming out of that angle. So these are going to be right angles. They are 90 degrees. Right angles. And then finally the last one. Looks like we have a octagon here. 1, 2, 3, 4, 5, 6, 7, 8. We're going to have, that's an angle. Anywhere there's a point is an angle. This is an angle, this is an angle, this is, and like our other shapes we've done, these angles will all look like they're congruent, but they are the same. So I really just need to look at one. Just looking at one of these angles, it does not make an L, it does not make a V, meaning it's going to be O for obtuse. It's going to be more than 90 degrees. Number 4, identifying the angles in the triangles below. Write A for acute, R for right, and O for obtuse. Whoop, up here. Pause the video for a second. Work this out. If you're back, you should have already filled this out. We have, this looks like a V here, so that's going to be A for acute. This does not make an L shape, nor does it make a V. So this is going to be obtuse. And then this is going to be another acute. Going here. Here we have a perfect L shape, meaning what kind of angle is that? That is a right angle. A V means acute and acute. A water sprinkler moves back and forth to water a lawn. The sprinkler turns through 90 degrees of a circle-shaped section of the backyard. So imagine this is your sprinkler head, and it's spewing water, but the angle that it's spewing water, only this part of the yard is covered. What kind of angle is formed in the section of the backyard that the sprinkler runs through? That would be your vertex right here, and this is at a 90-degree angle. So it's going to be a right angle. If the sprinkler is adjusted to turn through an additional 90-degree section of the backyard, how many degrees is the new angle formed by the section of the sprinkler the section that the sprinkler turns through? Well, instead of saying my sprinkler is going to go here, I'm going to expand it out and make it to where it's hitting this part of the yard too. So I took a 90-degree angle and I doubled it. And when I double a 90-degree angle, I get a 180-degree angle. Or you can look and see, oh, that makes a straight line. That's going to be 180 degrees because that is that's a benchmark angle. The sprinkler is adjusted again to turn through the shaded section of the circle shown at the right. The circle is divided into tenths. So what fraction of the circle does the angle run through now? Well, it only runs through 3 out of 10 parts of the yard, so 3/10. And then we're going to use fraction multiplication like we did yesterday to find the measure of that angle. So remember, we have a circle, which is 360 degrees. We have a circular, if you think of it, you have a circular yard, you have a 360-degree yard. Your sprinkler's running through 3/10 of your yard. The degree would be 3/10 times the 360 degrees of the yard. 3 times 36. 3 times 6 is 8. Carry the 1. 3 times 3 is 9. That's 10. So it would be 108. Yeah. 108 degrees. All right. Moving on to countdown. Day 11. What are the factors of 10? So we're getting a little bit more into our factors and multiples. We've been working with multiplication sentences for a while in the countdown. And so this should just, and again, this is a refresher. So if you're not sure about what a factor is, you need to go back in your math journal and find your notes that you hopefully took. So a factor is the two numbers we multiply together to get a product. So the factors of 4 are 2 times 2, 1 times 4. Whatever makes 4 is going to be a factor of 4. So what are the factors of 10? Well, we know that all numbers have a factor of 1 because 1 times the number is itself. So we have 1 times 10. What else can we multiply to get 10? 2 times 5. Are there any other, I don't know why I did that. Are there any other factors of 10? No. So our factors are 1, 10, 2, and 5. What factors do 36 and 42 have in common? Mark all that apply. So we're going to list our factors of 36. We would have, fix yourself. All right, so 36 times 1 then 2 times what? 2 times what equals 36? If you're not sure, we know that 2 is a factor of 36 because it is an even number. So if you're not sure, you can always divide it out. 2 goes into 3 one time. 1 times 2 is 2. We subtract. Bring down the 6. 2 goes into 16 8 times. So 2 times 18. What about 3? Does 3 go into 36? 3, and this is just a way to longhand it if you do not have your multiplication tables memorized very well. That's the only reason why I'm walking you through it like this. 3 goes into 3 one time. 3 times 3 is 3. That zeroes out. We bring down the 6. 2 goes into 6 twice. So we have 3 times 12. What about 4? 4 does not go into 36, does it? This is a common mistake. 4 divided by 36. 4 goes into 3 one time. That's 4. And can I do that? No, I can't. So that does not work. That's how quick I messed myself up. That's not going to work. 9 times 4 is 36, but that division did not work. I don't know what happened there. Alright, 36. Does 5 go into 36? No, because our multiples of 5 end in 5 or 0. And then we have 6, which we all should know that 6 times 6 equals 36. So there's all the factors for 36. What about the factors for 42? 42, we have 42 times 1. 2 goes into 42 how many times? If you're not sure off the top of your head, do your division again. It goes in 21 times. 3 does not go into 42 because it is an odd number. 4 does not go into 42. 5 does not go into 42 because it's even. 6 times 7. Here we go. So, did we answer our question yet? No, we did not, because we still have to find the ones they have in common. So, they're going to have 1 in common, because all numbers have 1. They have 2 in common. They do not have 3 in common. They do not have 4 in common, but they do have 6 in common. So it would be 2, 4, not 4, 2 and 6. Okay, perfect. And you can always go through and double check that by redoing all of your math. Like divide 3 into 36 and divide 3 into 42 and find out that that was not in common either. Number 3. Determine whether each number is a prime or composite number. Mark an X in the appropriate column in each number. So you got to remember what prime and composite means. Prime is a number that only has one factor pair, 1 in itself. Like 5 is a composite number because the only way to get 5 as a product is to do 5 times 1. Then a composite number has more than one factor pair, so 8 would be a composite number because you have 8 times 1 and 2 times 4. So let's think about 16. Is 16 prime or composite? What can we multiply to get 16? 16 times 1, and then 2 times 8, and then 4 times 4. So that's going to be more than one factor pair, so it's going to be composite. 13. We have 13 times 1, but can we multiply any other factors to get 13? No. So that's going to be prime. 12. We have 12 times 1, 2 times 6, and 3 times 4. So that's going to be composite. Then we have 9. 9 times 1, and 3 times 3. That's more than one factor pair, so that's going to be composite. And then 7, we only have 7 times 1. Number 4, the first number in a pattern 5, the pattern follows the rule add 3. What is the next number? So the first number in our pattern is going to be 5. The rule is you must add 3 to get the next number. So what would be the next number? We have 5, add 3, that's 8. So the next number in the pattern is 8. And you guys do not need to do number 5. If you do look at number 5 just to challenge yourself, I will walk you through what my thought process on it was. And then I will walk you through the process that Mr. Perez got when he did it. This was a bad question. I'm telling you guys, I'm not liking these number 5s on this countdown. Okay, so what I noticed was I looked at this in 2 different ways. I looked at it as in individual shapes, and then I looked at it as individual rows. Just like this. And what I noticed about the pattern was that however many shapes however many squares I had in a shape, 1, 3, 6, and 10, correlated or related to the number of squares I had in each of the rows, 10, 6, 3, and 1. Now what Mr. Perez found, which you know he is our personal math whiz, he found that in each new shape, a new row is added. In each new row, the number increases by 1 from the previous row. So he noticed that every time we started a new shape, we got a new row. In each new row, the number increased by 1. So we had 1, and then we added a row, and it increased. Then we added a row, and it increased. It was kind of confusing. The only reason I would really like this question is because it does require you to look at this picture in multiple ways. I was telling one of y'all yesterday over the phone, I was walking you through this, and I feel like you understood, but just to reiterate, when we're trying to find patterns, you have to look in different ways. Think outside of the box, essentially. Anywho, that concludes day 5. I will be at the school. Guys, listen up. This is important. I will be at the school from 10 a.m. to 3 p.m. Monday and Tuesday. If there's no way that you can send me pictures of your work, I need you to take what you have completed. I need you to tear it out of the book carefully. Do not rip the pages. And remember, this is only if you cannot send me pictures, period. If you already sent me pictures, you cannot come back and say, oh, I can't send pictures. Alright, so only for those that cannot send me pictures, you need to tear out the pages that you have completed out of the book. You need to keep them in order. You need to make sure you have your weekly checklists that you completed, and put that all together and make it nice and neat. And you need to have somebody come drop them off between 10 p.m. or 10 a.m. and 3 p.m. at the school Monday or Tuesday. Also, I need you guys to be very diligent in what we're doing. We are collecting grades. I'm working on progress reports as we speak. I will be calling everyone next week. And when I call you, we are going to do what is called a discussion-based assessment. This is where I ask you questions that pertain to what we have learned so far since we started this distant learning program. You have to participate in this call. If you do not participate, it will be a 0. So you have got to find a way to call me. I'm going to be really flexible with the hours. If mom only is home late at night, I don't care. Call me. And it's really quick. It's not going to take too long. And it's just, and it's going to be used somewhat as a quiz grade. All right. That's all I have for you guys. I hope you have a great weekend. And I shall, I'll be uploading Monday and Tuesday's videos this weekend because I will not be home Monday and Tuesday. I will be at the school, and I don't feel like lugging all of my stuff up there. So, again, as always, if you have any questions, feel free to contact me. I will include the links to the free math apps into this video. And so just go down below, click the link, and you can play around with the math manipulatives that app provides. All right. Bye, guys.